be going over question 6 on 2023 Euclid contest. Question A. A triangle of area 770 centimeters squared is divided into 11 regions of equal height by 10 lines that are parallel to the base of the triangle. Starting from the top of the triangle, every other region is shaded as shown. What's the total area of the shaded region? Okay, so to start this question off, we're going to draw an identical triangle and put it together with a graph. Well, let's just move it over. And now, as you can see, they form a parallelogram with each shaded line and blank line with having the same area. And because we know that there are 11 lines in total and 6 of them are shaded, therefore the area of shaded line in the parallelogram to the total area is 6 to 11, according to the line numbers. And because this parallelogram is made of 2 triangles, 1, 2, and each triangle has the area of 770. So we know the area of the parallelogram is 770 times 2, which is 1540 centimeters squared. And because we have the ratio between the shaded area and the area of the parallelogram, we can know that the shaded area in the parallelogram equals the area of the parallelogram times the ratio, which is 6 over 11, which is 1540 times 6 over 11. And because the question is only asking for the shaded area in one triangle, and our parallelogram is made of 2 triangles, to find out the answer, we're going to divide this number by 2. So the final answer would be 1540 times 6 over 11 times 1 over 2, which gives us 420 centimeters squared. Now let's take a look at part B. A square lattice of 16 points is constructed such that the horizontal and vertical distances between adjacent points are exactly 1 unit. Each of the 4 pairs of points are connected by a line segment, as shown. The intersection of these line segments are the vertices of square ABCD. Determine the area of square ABCD. Okay, so because the question already tells us that ABCD is a square and the area formula of a square is side length times side length. So to figure out the area, we only need to find out the length of one side of the square. And in this video, I'll be finding the length of AD. Okay, so because on the graph, as you can see, there are many points and they're exactly 1 unit apart from each other. Therefore, one way to solve this question is going to be using a coordinate system. So if I set this point to 0, 0, then this point would be 1, 0, and 2, 0, 3, 0, etc. And the only 3 lines that we care about in this question to find out AD is this line, and this line, because the intersection of them are point A and D. Therefore, we only need to show the coordinate of the endpoint of these 3 lines, and let's name them line 1, line 2, and line 3. If the first endpoint of line 1 is 0, 0, then the other endpoint is 1, 3. And for line 2, the endpoint would be 1, 0, and 2, 3. And for line 3, the endpoint would be 0, 3, and 3, 2. Okay. So the next thing we're going to do is to find the equation of each line. So for line 1, the slope is going to be 0 minus 3 over 0 minus 1, which would give us 3. And because one endpoint is 0, 0, so we know that the y-intercept is 0. Therefore, the equation for line 1 would just be y equals 3x. And for line 2, we're going to do the same thing, and because it's parallel to line 1, so we know they have the same slope. However, because neither of the endpoint of line 2 is on the y-axis, so we have to plug in number to find out the y-intercept. If I plug in 1, 0 into the equation, we will get 0 equals to 3 times 1 plus b, and b equals to -3. And the equation of line 2 would just be y equals 3x minus 3. And for line 3, we're going to do the same thing. Because line 3 is perpendicular to line 2 and line 1, we know that the slope is going to be -1/3. And because one endpoint of line 3 is 0, 3, so the y-intercept would be 3. And the equation would be y equals to -1/3 plus 3. And our next step is going to find out the coordinate of point A and D. Because D is the intercept of line 1 and line 3, to find out the coordinate, we can set the equation of line 1 equal to the equation of line 3. So that would give us 3x equals -1/3, x plus 3, 3x plus 1/3x equals to 3. 10x equals to 9, and x equals to 0.9. And if we plug 0.9 back into the equation of line 1, we will get y equal to 2.3. Therefore, the coordinate of point D is 0.9, 2.7. And for point A, because it's the intersection of line 3 and line 2, we're going to set the equation of line 2 and line 3 to be equal. 3x minus 3 equals -1/3x plus 3. And that would give us 3x plus 1/3x equals 6, which is 10x equals 18, x equals 1.8. And if we plug 1.8 back into the equation of line 2, we would get 3 times 1.8 minus 3 equals 2.4 equals y. Therefore, the coordinate of point A is 1.8, 2.4. Now, if we construct a right angle triangle over here and set this point to F, we can see that segment AD is the hypotenuse of the right triangle. And by the Pythagorean theory, we know that we can find out the hypotenuse, which is AD in this case, by using square root AF squared plus DF squared. And that would give us square root 2.7 minus 2.4 squared plus 1.8 minus 0.9 squared, which is going to be 0.3 squared plus 0.9 squared, and this will give us square root 0.9. And this is the length of AD. Because we're looking for the area of the square, so we can just figure that out by using the formula, which is area squared equals to side length squared. And in this case, side length is AD, so it's going to be AD squared. And this is going to be square root 0.9 squared. And that would just give us 0.9 as the answer.